And as far as state functions go, we'll talk more about these tomorrow, but their variables are S, which is entropy, H, which is enthalpy, G, which is Gibbs free energy, U, which is the total energy. However, some textbooks, Cindy, use the letter E to represent total energy, which kind of makes sense when you think about it. Energy, E. But a lot of books use U to represent energy as well. Our textbook uses U, so we will use U. Work. What is work? Speaking of work, I have some work that needs to be done. I need a box of textbooks to be taken down to the K-Wing. Each textbook is about 10 pounds. There's about 20 of them in the box. So I need someone to carry that box down to the K-Wing. But I also need someone to carry the instructions for the ideal gas lab down to Mr. Dow. So if I can have one person carry the box, okay, Brianna, which would you rather carry, the instructions or the box?
How heavy is the box?
Well, let's see, 20 textbooks, 10 pounds per textbook, about 200 pounds.
Oh, I'd love to do that.
Okay, so you're going to carry the box, and then I need someone else to carry the directions. You'd rather carry the directions, Ebersol? Okay.
Am I going to need some help with the box?
No, you just said you're going to take the box on your own.
I mean, yeah, I guess I'm pretty red.
But, what?
Wait, are you like being serious that you are?
So who's taking the directions? Ebersol, you're taking the directions?
Whatever you want.
Okay, well unfortunately, work is path dependent. Work is equal to the force times the distance.
Let's go.
If you are going to do work, you should ask the person, what's my path? Because Brianna, although the books are heavy, you get to carry them directly to the K-Wing. Jen, the path you are taking is down to Mexico City and then to the K-Wing. So, distance. Jen is going to travel a greater distance. Jen is actually going to be doing more work carrying paper than Brianna, because Brianna is going to get to go directly there.
Wait, what's F stand for again?
Force. Work is measured in joules. What's force measured in?
What?
Newtons.
Newtons.
Good old F equals ma. Come on.
A little hard.
Distance measured in meters. So a joule, 1 joule is equal to 1 Newton meter. This formula is the one you'll use next year more often in physics. You get to do these wonderful problems, Alex, like Billy Bob has to roll a barrel of beer up an inclined plane of 10 meters. The plane is at a 30-degree angle and the truck is 2 meters off the ground. How much work does he do? You know, practical things like that. We will use this equation. Work is equal to the pressure, negative pressure, times the change in volume.
Wait, is that one just like the...
Unfortunately, no, because we're not rolling beer barrels off planes. We're looking at gases and how their volume changes. Pressure must be measured in kPa. Pressure must be measured in kPa. Volume must be measured in liters. So a kPa times a liter is the same thing as a joule. Keep that in mind, Tom. So like I said, we are concerned with gases and pressures. And what you will see is a lot of piston problems. So there are two problems or two scenarios that we're going to do. Example 1, the piston is expanding. Yep. So I have my cylinder where the gas is. That's called the system. I'm going to call that my system. Everything else is going to be the surroundings. And I said that my piston is expanding, it's going up. Work is equal to negative P delta V. And delta V is equal to V final minus V initial. If I start going too fast, just tell me to slow down. I get kind of on a roll. V final minus V initial. Is that going to be a positive number or a negative number, Florak?
Negative number?
Big number,
Positive.
not a small number. Good. Right, because V final will be bigger. Getting bigger. No,
So it could be a negative number.
it would be a negative number. So in example 1, the piston is going up. So a negative pressure times a positive delta V means my work will be negative times a positive is a negative. So my work is negative. What does that mean? It means that work is leaving the system. In other words, the system is doing work on the surroundings.
What is that word next to the blue arrow say?
Which one?
Next to the blue arrow.
Work is equal to negative, meaning that work is leaving. Anytime you get a negative value, it's leaving the system. It's exiting the system. Anytime you have a positive value, Abby, it's going into your system. So let's compare this with when the piston contracts. So now my piston is going down, squishing the gas.
No, but this one contracts. Nice.
So now, what's my delta V going to be, Watsky?
Negative.
It's going to be negative, because my final volume is going to be smaller than my initial. So I have negative pressure times a negative number, a negative times a negative gives me a positive. So if it's positive, Claire, it means that work is going into the system. In other words, the surroundings does work on the system.
How does that work when the whole power source is created within the system?
It doesn't have to be. What we're looking at right now, it looks as if the system is where the power comes from, but it doesn't have to be. Just kind of like you could say, all the wolves in northern Wisconsin, that's my system. Actually, we killed off all the wolves in Wisconsin. So where did they come from? They came in from Minnesota. They came from the surroundings. So you can't have energy coming in from the surroundings. Now, somewhere in the surroundings, it has to be generating the energy to come in. And the same thing holds true with Q, heat. If Q is negative, heat is leaving. If Q is positive, heat is entering. So negative, you're leaving the system. Positive, you're entering the system.